screen here. Okay, so we are going to talk about how to solve radical equations today. What we do today, not too bad, because solving radical equations is going to be super similar to just solving kind of normal equations. So our typical approach to solving equations is using inverse operations. Okay, so kind of taking it back to the beginning of the year, we had 1 or 2-step equations. So if you are solving a 1 or 2-step equations, first of all, one of the biggest rules, and this is true for whatever kind of equation you're solving, we know that what you do to one side, you have to do the exact same thing to the other side. At the very beginning of the year, we drew the line down the equal sign, and we just kind of showed, okay, what you do on this side of that line, you need to do on the other side. But then how you know what you're supposed to be doing on both sides is that idea of inverse operations. So what I'd like to do is kind of review these inverse operations that we already know, and then I'm going to add one to it that we actually maybe kind of already know as well. So the first and most basic operation we have in math, that's probably the first one that you learn in, I don't even know, first, second grade maybe, is addition. And if you have an equation that says x plus 3 and you need to get rid of the plus 3, addition undoes subtraction. I guess it would technically be the other way around for that, but they undo each other. If you have addition, you're going to do subtraction. If you have subtraction, to undo it, you're going to do addition. They undo each other. And the next one would be multiplication, and the opposite or the inverse of multiplication is division. Okay, so those are kind of your 4 basic operations that we kind of always start with in math: addition, subtraction, multiplication, division. But there are other operations, in a sense, that we've talked about so far, okay? One of them is we can square a number. Take x squared. We actually talked about this last chapter in chapter 9. If I had x squared and I wanted to get rid of the squared, what undoes a square? Square root. Excellent. So that's what we did last chapter. But just how, if you have addition, to undo it, you're going to do subtraction. And you can go back the other way. If you have subtraction, to undo it, you're going to do addition. It works this way as well. If you have a square, to undo it, you can square root it. If you have a square root, to undo it, you're going to square it. And that's really the big idea for today. So there are a couple of things that we do need to watch out for. So to solve a radical equation, the first thing you want to do, you want to isolate the radical. And the entire radical and anything under it. Okay? So we'll get to this one here in just a second. But what I mean by that is I want to isolate this square root of x minus 2. I want that to be all by itself. And then what I can do is I can get rid of the square root by squaring both sides and then solve your equation. Now, one thing to note, it's not going to come up today. I'll kind of ruin the surprise for you guys, but it will come up tomorrow. When you do this, when you end up squaring both sides, we'll talk about it tomorrow, there's a possibility you could, in a way, create an extra solution. Not going to happen today. We'll talk about it tomorrow. But we're going to get in the habit today. You have to check your answers. Once again, I'll show you tomorrow how this happens, but you have to check your answers today. It's not an option. You have to check your answers. Okay? So, for this equation right here, the square root of x minus 2 plus 3 equals 10. So what you want to do first, the radical and anything underneath the radical, you want to be all by itself. So what I have highlighted here, I want that to be the only thing on that side of the equal sign, which means I need to get rid of the plus 3. I need to get rid of the plus 3. Okay, subtract 3 on both sides. So now I have the square root of x minus 2. 10 minus 3 is 7. Now here's the thing. Although it may be tempting to go ahead and add 2, you can't. Because that 2 is under the radical. It's not technically a 2. It's not even really a square root of 2. It's underneath the radical. You cannot take numbers in or out of the radical. No questions asked. You cannot do that. So once it gets to this step, if I can't take anything out from underneath the radical, but I still need to solve for x, the only other possible thing to do is to get rid of the radical. So to get rid of a radical, to get rid of a square root, what do we say up here? What undoes a square root? Square, yeah. So you're going to square to get rid of the square root. But we know if you're going to square one side, you have to square the other side as well. Now what happens? Just like when we did completing the square, it kind of looked like this, just the opposite, because I had a quantity squared, and to get rid of the quantity squared, we square rooted it. And remember how the square and the square root cancel each other out? It's the same thing here. The only thing left is x minus 2. And on the right-hand side, 7 squared is 49. Now this is just a one-step equation. So to solve this, we would add 2, and we get x equals 51. Now, like I said, you absolutely 100% of the time have to check your answers, even if it's just in your head. And these are pretty easy to do in your head. If you plug 51 in for x, 51 minus 2 is 49. Square root of 49 is 7. 7 plus 3 is 10. It works. Even if it's just in your head, you have to check your answers. It does, and that's all it does. Yep, the square and the square root, they're totally gone. It doesn't do anything with the numbers underneath it. Okay, let's get this glued into page 63. Does that sound right? Section 10.4, solving radical equations. Okay, so big thing, remember, to undo the square root, you are going to square both sides, but you cannot square both sides until that square root is all by itself. That's going to be the biggest thing today. So number one, if I have the square root of y plus 6 equals 12. So I think what helps sometimes is to kind of recognize, here's my radical. Maybe put like a box around your radical and everything underneath the radical, because remember, you can't take things inside and outside the radical. And what we need to do first is we need to isolate that box, okay? That box needs to be the only thing on that side of the equal sign. So in this case, right, the equal sign is right there. So the thing I need to move is that plus 6. So to move the plus 6, we would subtract 6 from both sides. So I'd have the square root of y equals 12 minus 6 is 6. Now that it's the square root of y, remember I can't take anything out from under the equal sign. It wouldn't even really help me here and now because it's just a y. So to solve for y, the only thing I need to get rid of is that square root. And we know what does a square root. Yeah, squaring it. And we also know that if I'm going to square one side, I have to square the other. Just like in the first example, the square and the square root cancel each other out. We get y equals. And on the right-hand side, 6 squared gives me 36. Now also remember, guys, and this is not optional, you have to, even if it's just mentally, check your answers. If I plug back in 36, the square root of 36, 6 plus 6, 12. It works. Okay? Number 2. Okay, the square root of 4n minus 6 equals 0. So once again, if it helps, okay, first thing you might do with a highlighter, with a pen, just with your pencil, just put a box around that square root. And anything underneath it, because remember, I can't take things in or out of my square root. So, I have my box. I want that box to be the only thing on that side of the equal sign, and in this case, it's not. How am I going to get that box all by itself? Yeah, we're going to add 6 to both sides. So now we have the square root of 4n equals 6. Now remember, the whole point here is to solve for n. So I've got the square root and I've got the 4. Those are all the things to get the n all by itself. But in order to get rid of the 4, it's under the radical. Remember, I cannot take that 4 out from under the radical. So what I need to do next is get rid of the radical. And how do we get rid of the radical? With the square root. Square both sides. Now remember, guys, the square and the square root, they are completely gone. You don't square anything. You don't square root anything. The 4n is all that's left. And on the right-hand side, 6 squared gives me 36. Now it's a one-step equation. Now I can divide by 4, and I get n equals 9. Go back, even just mentally check your answer. 4 times 9 is 36. Square root of 36. 6 minus 6. 0. It works. Okay, number 3. All right, let's say we have the square root of 3x plus 3 equals 6. Once again, if it helps, put your radical, put your square root in a box. If it helps. Because you know that that box needs to be the only thing on that side of the equal sign. Now in this case it is. Remember, yes, I need to get rid of the 3 in front of the x, and yes, I need to get rid of the plus 3, but both of them are underneath the radical. You cannot, under any circumstances, take numbers out from underneath the radical. So if I can't take any of these out from underneath the radical, my next step is to get rid of the radical, to get rid of the square root. So for this one, my first step is actually going to be to square both sides. So just like the other ones, the square and the square root are totally gone. All that's left is what was underneath, which is 3x plus 3. And on the right-hand side, 6 squared gives me 36. Now, two-step equation, subtract 3. 3x equals 33. Divide by 3. Should get x equals 11. Make sure, plug it in. 3 times 3 is 33. 33 plus 3 is 36. Square root of 36 gives me 6. Not too bad today. Okay, today's pretty simple. Okay, number 4. The square root of 4p minus 8 equals 8. Now remember, this is what we are trying to isolate first, that square root. Is my square root isolated? Yeah. Yeah, it is. So we're ready to get rid of the square root, which we can do by squaring both sides. Remember, when you do this, you're not squaring any of the numbers. You're not square rooting any of the numbers. They're gone. You just get 4p minus 8. Now on the right-hand side, you are taking 8 squared because there's no square root to get rid of over there. So 8 squared would give me 64. And then to solve my two-step equation, add 8. So 4p equals 72, which means p equals 18. Double check, plug it back in. 4 times 18 is 72. 72 minus 8 is 64. The square root of 64 gives me 8. Okay, just a couple more. Alright, number 5. 6 minus the square root of x equals negative 4. Alright, so remember, the radical, the square root, and anything underneath it is what needs isolated. That needs to be the only thing on that side of the equal sign. Is that the case here? No. And I've got a couple of things. The big thing that we see is the 6. Remember back from our 1 and 2 step equations. How am I going to get rid of the 6? Subtract 6. Very good. Because this is a positive 6. So we're going to subtract 6 from both sides. Now, that negative sign is still there. It's negative square root of x. And negative 4 minus 6 is negative 10. Now, one of the things I always have students try to do, I have a lot of students try to distribute inside of the radical. So like distribute the negative inside the square root of x. Just how you can't take numbers out of the radical, you can't put numbers in the radical. So if I can't distribute the x into the negative into the radical, I still need to get rid of the negative. And just like if I had an equation that said negative x equals negative 10. Now if I had 1, I want you guys to watch this because I'm going to love that you guys finish that. If I had 1, this is going to be negative square roots of x plus 1. Is that what I wanted to do? No. How would you get rid of this? There we go. Divide by negative 1. Because look, a negative over negative 1, that's just going to give me the square root of x. And on the right-hand side, negative 10 over negative 1 is just going to give me a positive 10. Now the radical is by itself, so we can square both sides. So we should get x equals 100. Same thing, double check your answer. If I plug this in for x, the square root of 100 is 10. 6 minus 10 gives me negative 4. Okay, last one. Number 6. The square root of negative 5t minus 1 equals 7. Okay, so remember the square root and everything underneath it needs to be isolated. Is my square root isolated? Yes. So what's my first step here? Yeah, we're ready to square, because remember I can't take any of those numbers out from underneath the radical, so I need to get rid of the radical. Remember, when you do this, nothing happens to the numbers underneath the square root. It stays negative 5t minus 1. You are going to actually square the 7. Okay, 7 squared is 49. And then our two-step equation here, add 1, negative 5t equals 50. Divide by negative 5. We should get t equals negative 10. Double check your answer. Negative 5 times negative 10 is a positive 50. 50 minus 1 is 49. Square root of 49 gives me 7.